recording.
Okay, good morning. Let's get started. My name is Eugene Olevsky, and I'm the Dean of the College of Engineering at San Diego State University. Welcome. I would like to introduce also a few people. Student Affairs Coordinator Donovan Geiger, Outreach Director Luis Tapiri, and as well as our IT lead, Ku Moa, who are all present here. You will also meet engineering faculty and students in a few minutes. We very much appreciate your commitment to learning and to continue to forge your academic path. You have all persevered in these pretty extraordinary and challenging times, and you are making very important decisions about the next phase of your education. I can tell you one thing for certain. The strengths of an institution of higher learning like San Diego State University and the value of the education you will receive can and will endure any storm. We all needed to adapt previously during the time of pandemics, but the core values of our university and the fundamental quality of the engineering program remain unchanged. We must look forward and look toward the future and prepare to meet it. In many ways, engineers have the task of building a better tomorrow. So you can set yourself on no better course, and there is no better place to begin than San Diego State University and our College of Engineering. Next slide. Today, we are excited to share with you the details of the stellar education you will receive at our College of Engineering, which I know you will all find intellectually rigorous and immensely rewarding. Our College of Engineering is presently undergoing transformative changes as never seen before. Our faculty, staff, students are experiencing incredibly exciting time. During the previous 10 years, the student enrollment has more than doubled in our college, and our college is one of the most active powerhouses in producing the engineering workforce for this whole country. All of our engineering departments are among the 25 top public engineering schools in the United States in terms of the graduation of the new engineering workforce. In general, one of every 19 US engineers graduates from the California State University system. At the same time, our research productivity more than tripled during the last 8 years. We have recently added a new major, and that happened last year, in construction management. And as you can see on this slide, we have 8 undergraduate programs with additional opportunities at the master's and also doctoral levels. Next slide, please. There are numerous opportunities in every one of our disciplines. They include hands-on learning. Our college is really very famous in providing very hands-on oriented curriculum. So our graduates, they are ready from the day one to accept jobs in engineering and engineering applications. We also have renowned faculty. We have renowned faculty, and they conduct actively top of the notch research. Also, we provide opportunities for students for studying abroad. And we have a very, very supportive community, which includes faculty, staff, and the students themselves. Our college has already achieved the status of an absolute benchmark of excellence in a number of scientific research areas. I would like to provide a few examples. Due to the successes achieved by San Diego State University researchers in an important area of materials engineering called sintering, San Diego is considered to be the sintering capital of the world. And sintering is related to the emerging technologies of additive manufacturing, also known as 3D printing. The groundbreaking work in the area of signal processing in terms of the underlying principles of our modern cell phone communications was carried out by SDSU, our college researchers. San Diego State University Aerospace Engineering Department is a national and international leader in advanced aerospace guidance research. Also, SDSU is world renowned in wireless power transfer research. When transmitting or supplying electric power, this technology can eliminate the use of wires and batteries, thus increasing the mobility of electronic devices and making them more convenient and safe for all users. You will see also the presentations of our renowned faculty today, which will add to this list of very strong, outstanding achievements of researchers at our college. The San Diego State University Rocket Project, that's a student club. It set the collegial rocket launch world record of reaching more than 13,000 feet by rocket in altitude, and this happened just the year before the last. 3 of our college affiliates participated in the guidance and landing control of the Mars Perseverance mission, and that included one recent graduate of our aerospace engineering department. She is now employed by the Jet Propulsion Laboratory, and 2 mechanical engineering students in the capacity of interns at Jet Propulsion Lab, where they were also working in the framework of their senior design projects. Next slide, please. So to tell you more about the exciting opportunities at San Diego State University, at our College of Engineering, we have a few guest speakers to share their experiences. You can see the list of the speakers here on the slide. Next slide, please. We'll start with Dr. Alicia Kinoshita from our Civil, Construction, and Environmental Engineering Department.
Thank you, Dean Olevsky.
Next slide. Yeah.
Thank you, Dean Olevsky. I'm glad to be here. Hi, everyone. Just to introduce myself, I am an associate professor, as Dean said, in civil construction and environmental engineering. I'm also the director for undergraduate research and creative activities on campus. Just to give you a little bit of background about myself, I did all of my degrees at UCLA, and then I spent a couple years in Colorado doing a postdoc. So as this picture on the left shows, that's one of my favorite offices is usually being outside, an outside office. So I've allowed my career to go from research at a computer and in the lab or classroom to trying to take things outside as well. And so some of my hobbies were tennis, camping, and traveling. And I say were because now I have a 1-year-old son, so that is my hobby nowadays. But yes, that's a little bit about me. And I specialize in hydrology and water resources. Oh, next slide. Ooh, thanks. Forgot. So I've specialized in hydrology and water resources. In the classroom, what I like to have students practice are hands-on learning through things like field trips. So in this upper left picture, that's actually, I've taken classes to the San Vicente Dam. I just had a class go to El Capitan Dam. So we have tours with like the city of San Diego, really good relationships with them. We also practice our hands-on learning through live demonstrations in our hydraulics and water resources lab. So in the upper right and middle right, we have kind of a larger flume and a smaller flume, which allows us to apply and test the theories and equations that we're learning in the classroom and in the textbooks. I'm also teaching a field hydrology class, so I like to get the students outside. We're collecting data, and that's again allowing us to kind of practice taking these measurements and validating all of these parameters and things that that we're seeing. Next slide, please. Outside of the classroom, I'm very passionate about research, and I was engaged very early on as an undergraduate student in these sort of high impact practices and projects. And so I really like getting students involved and working with them as well. So what do research students do? Well, we try to, we're not just researching, but we're learning and practicing our leadership skills. My work is very interdisciplinary, so we're not just working with civil engineers, but we're collaborating with other engineering disciplines and other environmental sciences, geography, geology, and we have collaborators at places like JPL. I know Dean Olewski mentioned that as well. We work with folks at CAL FIRE, so it's a really great opportunity to kind of network and problem solve and practice your communication skills. So in these images here, I've got some students in the field, students that are working with environmental engineering components in the lab. So there's Ray Becerra on the right side. And then in the middle is Sophia. So we like to send students to conferences as well. So they can be local, national, regional, but I try to send them around, and it's a great opportunity, great experience. Next slide, please. Okay, so just to give you a little bit of a feel with who I work with both graduate and undergraduate students. As I said, I was engaged early on as an undergrad, so I find it, very rewarding to work with undergrads. And sometimes you guys are even more hardworking and dedicated than my graduate students at times. So you can see here, these are some of the current students that I'm working with, and it's of all levels. I think Emily is she's probably a junior now. Kathy's a junior as well. Anahi's a transfer student. And then I've got in the box on the bottom right corner there, these are 2 internship students that that we're going to work with this academic year from San Diego City College and Mesa College. So but I love working with students of all ages, from first year all the way to your senior year. And then they also kind of work in tandem with our MS thesis students. And so while working with us, we're trying to, you can't work for free. I hate that. So I'm trying to make sure that you're getting some funding or trying to get compensated for your work in some way. Next slide, please. So my lab is called the Disturbance Hydrology Lab, and some of the research methods that the students practice is, again, where we have a lot of this heavy emphasis on field work, going out and collecting the data, but that's not often very feasible. If you've been hiking or anything before, you know how difficult it can get to go out to these remote places. So we also incorporate things like remote sensing and the big data sets so that we can fill the gaps. And then we can try to model our systems. So in the next slide, please. Those methods are then applied to trying to answer some of these questions, research questions, hypotheses, or trying to answer our research goals. So, really we're trying to understand changes that are following disturbances, whether they're sort of more natural like wildfires, or human disturbances, fires caused by humans, or looking at the different infrastructure and then trying to predict how our system is changing. So if you're interested in any of that, feel free to check us out. We have an Instagram and a website, and you can always reach out by email. With that, I'd like to introduce my great pleasure, Dr. George Yusuf.
Thank you, Professor, for the introduction, and thank you everyone for being here. And thank you for the college administration for giving me the opportunity to be here with you today, give you a little bit background about what we do in my lab. So the lab is called the Experimental Mechanics Laboratory, and we focus in mechanics of lightweight and multifunctional materials. And then I have here plus people because as Professor Kinishoda have the interest in working with undergraduate and graduate students. It's a common theme in our university that we like to engage students from all academic levels in our research. I am a professor of mechanical engineering and the principal investigator of that lab, the Experimental Mechanics Laboratory. So giving you a little bit, next slide, about the what the lab is called. So the lab is the Experimental Mechanics Laboratory. So our mission is a two-part mission. The first part of it is advancing mechanics, and I will tell you about that in the next slide. But for now, we wanted to focus on the second part of the mission, which is broadening participation in engineering, meaning engaging students from all academic levels in our research. Next animation, please. So in the idea of mechanics, we're really focusing on mechanics of non-traditional materials. Earlier in the previous slide, I talked about mechanics of lightweight and multifunctional materials. It will become clear when we move on through the presentation. But for now, the next animation, please. We also focus on broadening the participation in engineering. We have a specific focus that we developed since we founded the lab in 2012 in engaging underrepresented minorities and women in hands-on experimental research to be able to advance their career, but also contribute to the global and national research ecosystem with different perspectives and different opportunities. Next animation, please. So our lab has been funded over the years since its inception in 2012 by a variety of different organizations, federal, state, and even private companies. The dean and my colleague have talked about these different sources. The idea here is research is expensive. It requires a plethora of tools, but also requires people to do conduct this research. So we seek these funding opportunities to provide you with the resources needed to perform that research. Next animation, please. So here is a snapshot over the years from the group. As you can see here, it changes size and changes composition throughout the years. We are showing here on the right the biggest the group can ever got, and this is composition of undergraduate students, in the different academic level from freshman to senior, master students, and even PhD students are shown in this picture. Next slide, please. So animation. So these materials that we talked about, so we talked about non-traditional materials. Is the beginning of them is polymers. So plastics are everywhere. If you look around the room and if you look around your car or a plane, you'll find that they are used in every domain, industrial domain. And our focus really is to understand the mechanical, thermal, dynamic, and physical behavior of these interesting class of materials, so we can design or develop superior armors, such as the helmets used in football, or also used for soldiers in the army or the navy. And our research have yielded very interesting results. The material that we worked on early in my career is now the standard protective layer for the next generation of marine helmets. So saying that the research you do in the lab has an application outside is of a great interest. Next one, please. We also work with these composite materials. These materials are made of multiple phases, so maybe polymers and then fibers. All of you have heard about aerospace composite materials. These are used for constructions of civilian and military aircraft. So we wanted to really understand how these materials behave. How can we use these materials, not just in the aerospace industry, but maybe in the biomedical industry, creating new prosthetic devices, both internal and external, so we can actually improve the survivability of these implants, extend their lifetime from few years to hopefully the lifetime of the patient. Next slide, please. So now we talk about the multifunctionality. Materials generally are used for a single function. The door in your car is the outside panel is just used for that. But how about if we can make the door is more than just a door? So another way the door will be able to capture or harvest energy both from the wind while you're driving, but also from the sun. How about if the door can transmit the electricity when you close it, and so on and so forth. So this is very important, specifically for spacecrafts, where your weight penalty is very costly because you cannot go and refill the spacecraft once it's launched. So we have worked extensively with JPL on developing a new multifunctional structures that they can be used for load management, carrying the load of whatever applied to them, but also used for heat management, fluid management, electrical distribution, and even electromagnetism transmission. So this idea here is that we use these materials, or we try to investigate these materials for different applications. Next animation, please. So if we want to summarize what EML does, really basically just lightweight and multifunctional materials. Anything has to do with that, we work with. We work that from an experimental point of view, from an analytical point of view, and from also computational point of view. In simple terms, what we do is we make materials and we break them, and we do that every single day, 7 days a week, 365 days a year. Make different materials and see how they break so we can use them for different applications. Next slide, please. In addition to that, we're really interested in providing an outreach and engagement experiences for both high school and undergraduate students. It's really, you're seeing here pictures from different cohorts. We have 2 summer programs. One is focused for undergraduate students, we call the Junior Researcher Experience, and one focus for high school students, we call the Junior Engineer, the Young Engineer Experience. And using the word experience instead of programs is kind of important because, as you see from these pictures, there is really hands-on collaborative opportunities that we provide. So, and it's not really a hierarchical. So you see here me working with my students hands-on. You see the students having fun, making and breaking things. You see them working. So in the bottom middle picture is these are 4 high school students working with a PhD student on a project over the summer of 2022. So next slide, please. So the point here is to build your skills. I like to say shape and sharpen your technical and interpersonal skills, working collaboratively with others. And the only way we can do that, as Dean Levsky said in the beginning, is by giving you hands-on immersive experiences. And we do that by inviting you to the lab and giving you a research project that you work on, whether even during the summer or during the academic year, or it can extend over multiple academic sessions. Next slide, please. So I wanted to thank you for giving me the opportunity to be here. And I also wanted to thank the people that, or the agencies that have funded us or continue to fund us over the year. And a specific thank you to my students. Over the years, they make the lab what the lab is now. And I'm very grateful for all the opportunities. Before I leave you, I wanted to go, next slide, please. And I want to leave you with this quote here. I think it's an amazing quote. And the main takeaway from that is dare mighty things. Always strive for excellence and go forward. At SDSU and my lab, we don't just dare it, you expect it. So we like to say, expect mighty leaps. Thank you so much for the opportunity. And I would like to introduce Audrey as our students to take it over from here.
Hi, everyone. My name is Audrey Chwakai. I am an undergraduate student majoring in computer engineering, and I also have a minor in entrepreneurship. So if we go to the next slide. So currently I am the College of Engineering Digital Communications intern. And now I'm going to talk about my involvement here on campus. So first, I was part of the executive board for the College of Engineering Student Council. My first position was the vice president of outreach, where I was in charge of the mentor program. Then last year, I was the vice president of marketing, and I was in charge of the social media, making flyers, and just getting the word out about events. And then that was when we were awarded with the Aztec Achievement Award for Outstanding College Council. And for all 4 years, I was part of the MESA program. They offer so many resources and events, and I think my favorite one would have to be the STEM Shadow Day, where you get to visit a company's campus and learn about what they're all about. I am also a member of the AB Samahan org on campus, which is basically the Filipino club, and The Look, which is the fashion magazine here on campus, and I was the VP of marketing. And next slide. Okay, now about my internships. My first one was the CSU Summer Bridge intern. I basically tutored incoming freshmen and helped them be ready for their classes in the fall. And my second one was for NIWIC, the Naval Information Warfare Center. I basically did testing and debugging for the current programming that they had. And I found that one through the San Diego State University Research Foundation. And my next two are both from the Zip Launchpad Startups, which is the startup incubator here on campus. And I was a graphic design intern for a startup called Evolve, and a software developer intern for a startup called XRA, which is basically turning 2D games and making them be able to be played in 3D reality. Thank you. And I will turn it to Donovan, and he'll talk about student support.
All right. Well, thank you very much. In case you forgot, my name is Donovan Geiger. I'm the Student Affairs Coordinator for the College of Engineering. And I'm just going to talk to you about a few things here. Some exciting things like advising, which is, we've actually made some leaps and bounds in this area over the last couple of years, and we brought in a whole bunch of professional staff advisors that each one of you will be assigned once you're here in the College of Engineering. And they'll help you plan out all of your academics all the way to graduation with a master plan, which is a fantastic thing that we have here to make sure that you keep on track and graduate on time. And they'll help you, guide you throughout your entire academic career, and always available to you. We also have lots of other areas of academic support here through our Center for Student Success in Engineering, or CSSE. And we've got peer advisors there. So sometimes you don't want to hear it from faculty or staff or anybody else there other than another student. And you can go in there and talk to them. They're usually juniors and seniors, and they'll be in your major. And you can ask them all sorts of questions about their pathways and what they've done at SDSU, maybe some of the student organizations they've joined, the professors they like, undergraduate research, all that good stuff there. And they'll even be able to give you some recommendations on classes and how they navigated their own major. So lots of great support there. We got even tutoring and everything there. We want to make sure that all of our students are taken care of in all areas. Of course, we know engineering is a pretty tough field to get through, but we've got lots of support for you here, and we'll make sure that you're able to do it. We also will start you off with an orientation session here. It's an all-day affair, and you will bring your parents into that as well, and make sure that you learn everything there is to know about SDSU and engineering. And it really is a fun day, and you'll have a lot of excitement here, and you'll get to meet myself and the assistant dean and many other folks that work at SDSU. But one of the favorite things that I love to always talk about here is our student organizations. I think this is what really sets us apart at SDSU. SDSU Engineering, is that we do have so many hands-on opportunities through our student organizations. I could talk to you for hours about this. So if everybody wants to hang out for another 3 hours, is that okay with everyone? I think I heard a couple of yeses there. Is that all right? I'll try to make it as quick as I can here, but I'll highlight a couple of organizations that we have. You can do just about anything through the professional side. So we have professional organizations like the American Society of Mechanical Engineers, or the American Society of Civil Engineers, or AIAA, which is the American Institute of Astronautics and Aeronautics, and several others out there. And these organizations will exist all the way into your professional lives after you graduate. Many people in professional industry, and our professors as well, are members of these organizations. And they do many different types of competitions and networking and outreach and things like that. So these are definitely groups that you want to join once you get here to SDSU. We also have others like, say, Society of Women Engineers, SWE, which is a great group, one of our most active student organizations here in engineering. And we also have our competition teams, those that are actually putting together big projects like Aztec Electric Racing. They build an electric vehicle every year. They are one of the top ranked racing teams in the country, in the world. In fact, it is an international competition. And they just put together a fantastic electric vehicle every year. We also have Aztec Aero, which builds, they compete in design, build, fly, which they put together kind of a drone, and they race that against other universities internationally. They do a fantastic job as well. We have Mechatronics. They build an underwater autonomous vehicle, basically a submarine that pilots itself. And they are pretty much the top ranked school team in the entire world. Really an incredible team that we have. So if you want to get involved in some autonomous technology there, it's a great one. And we also have Rocket Project. I'm their advisor, so I'm going to shamelessly plug them for about an hour here. But they are just an incredible team. They are putting together something that very few other universities can do, and that is a liquid-fueled bipropellant rocket. The one coming up right now is going to be a 2-stage rocket that they're putting together. And this is really something that very few universities can do. Our target right now is to reach the Kármán line, which is the barrier into space, that line. It's about 330,000 feet up there, or 100 kilometers. So that's really something that nobody else has done. We hold the world record in altitude right now for our previous rocket. And we are going to be the first university in space. I promise you that. So it's a great reason to come and join us. It takes all different types of engineers to put that rocket together, and it's really exciting. So I can't stress it enough how much we want to put all of our students in the field and get your hands on everything, and put all of that theoretical knowledge you learn in the classroom into practical use. So we also have internships here. We have our very own internship and career coordinator that works with us, and she'll be able to connect you with companies all throughout San Diego and the wider region, and get you that internship that you've always been looking for. And many of those really turn out to just be long job interviews. And many of our students will continue on through the internship right on into a full-time career once they graduate. So lots of opportunities there. We'll make sure that you get paid if you want to get a good job as you're a student here. And like I said, hopefully that'll convert into a full-time job once you graduate. And we've got study abroad opportunities too. Not too many places offer engineering specific study abroad, but we do that here at SDSU Engineering. Lots of places that will take you all over the world. We have independent study abroad too as well. If you want to go anywhere in the world, I mean, if you want to go to the middle of Mongolia, we can make that happen for you. But we've got lots of different opportunities out there. We've got faculty-led programs to Germany and Poland. We've got one coming up to Panama here. Really exciting programs. So if you want to make that a part of your portfolio and put that on your resume, we definitely have study abroad opportunities there too. So I'd also like to highlight here at the bottom, Access SDSU. And, really, a big part of making your final decision when picking a school is making sure that you can be supported academically, financially, and personally. So, let us do part of that work for you. And so we want you to be able to get connected, stay connected with SDSU Engineering by signing up for Access SDSU. And this is a digital experience that'll be a year-long relationship that will help you learn more about the program, services, and organizations that are here for you at SDSU Engineering. So you can scan that QR code right there or follow that bit.ly link. Really want to encourage you to join that so you can stay in touch with us throughout the next year. And we'll go to the next slide here. And I think that's pretty much going to wrap it up for us. We'll open it up at this time for any questions. If anybody would like to just open up their mic, you can do that now, and you can ask us a question, or you can throw it in the chat. Either way, whatever you're comfortable with. Any questions out there? Come on, I know we've got some questions. Was our presentation that good? We answered every question knowable.
Anybody who wants to ask questions, you can raise your electronic hand in particular, or you can put some message in the chat. Okay, we have one message.
Yeah, we do have some recommended computer specs that are on the engineering website. If you just go to engineering.sdsu.edu, we have some information under our student areas there that'll tell you all about the computer recommendations we have. Even if you don't want to go out and spend a bunch of money on a brand new computer, all the software that you will need to get through engineering is available in our labs too. So we've got lots of opportunities there. So don't worry about that. But if you do want to check out those computer specs, we've got them all up on the engineering website. And looks like we've got another question there. Average time it takes to graduate. We are targeting 4 years. That is the average time for most engineers now is we'll hopefully get you out in 4 years. That includes a little bit of summer school there. Yeah, we can definitely get you rolling in 4 years, provided you follow your master plan, and we'll help you do that. Most of the software we do recommend Windows. A lot of engineering software runs on that platform. You can do it on a Mac. You've got to run boot camp and do some things like that. But if you can, we do recommend staying on the Windows side, a little bit cheaper too. But yeah, you can make it work on the Mac side if you do want to do that too. Is it better to apply as undeclared or as an engineering major? 100% apply as an engineering major. Definitely want to recommend doing that so that you get built into the college, that you come to our orientation session, and that you'll be set up as a pre-major in one of our engineering majors, and that will get you all set up with advising and everything else ahead of time. So it is much, much easier to come into SDSU academically and getting set up with us rather than as an engineering major rather than doing it undeclared. So definitely want to recommend.
If you apply as undeclared, it is absolutely not automatic to convert, to change the major. So please keep this in mind. Therefore, it is 100%, as Donovan mentioned, better to apply as engineering major.
And let's see, we got another question there. Are all engineering fields and lectures located at the same part of campus? They're generally around the engineering building, but they can be anywhere. You know, it's a fairly urban campus that we have. So, you know, you won't be walking for miles to get from class to class. Even if you go from one side of the campus to the other, it's not going to take you more than 15 minutes. Teacher student ratio, that really depends on what year you are. If you're starting off as a freshman, obviously that's going to be a little bit higher. And that decreases as you get into your upper division courses. It depends on department as well, what your major is, a lot of different factors there. So it can be, you know, we have undergraduate courses that can be well over 100. And of course, we've got upper division courses that will get you down into the teens and 20s. So definitely a wide variety there. And a study abroad realistic for an engineering major at SDSU? Absolutely. Like I said, we've got faculty-led programs. So we've got professors from right here at SDSU Engineering that will take you overseas, and they teach a regular SDSU summer or winter session course. So you don't have to worry about transferring units back, and they get plugged directly into your major, so you won't lose any time at all. In fact, you're accelerating your degree. So it definitely is a realistic opportunity if you want to study abroad. Absolutely. And let's see, for an engineering major, do we take engineering related courses throughout our 4 years, or is it just the last 2? Obviously, you're going to have many more engineering related courses towards the latter half of your studies here, but you will start off right as a freshman taking engineering related courses. So we're going to build you up. You know, you're going to be taking things like calculus and chemistry and physics and that sort of thing, the foundations of engineering, but there are some regular major related courses that you will take as a freshman as well. Is applying to engineering harder and more competitive to get into in comparison to other schools? So there's really at SDSU, there's not really an easier pathway to get in to the university if you're picking a particular major rather than another. So you're fine just selecting engineering. We definitely don't recommend trying to get into SDSU by, say, picking a degree over in arts and letters or business or something like that, and then trying to transfer into engineering. In fact, that might even be harder to do. So definitely select engineering as you're applying. It's not going to give you any plus points or minus points either way. So we do want to encourage you to do that, to select an engineering major as you're applying. Does anybody from admissions want to jump in and chat about that process? Or
yeah, I can touch just really quickly on that. Hi, everyone. My name is Taylor. I'm one of the admission counselors over in the Office of Admissions. Really, the one thing I just want to say is in terms of the way we admit students, it is by major. So for example, if you are applying to civil engineering, all the students who apply for civil engineering will be ranked kind of in one list, and then we will admit for civil engineering, and then students who are applying for say mechanical engineering, that's a separate kind of list. There is no benefit to say applying undeclared or to another major. All of our majors are impacted to some extent, and we have about a 32% admissions rate for last year's first year and transfer students. So that's just a little bit about the admission side, but we always recommend, if you know that you're interested in engineering, and particularly one of the emphases, to definitely indicate that on the application. It just streamlines the process into SDSU and into the engineering major.
all right, thank you. And we've got some more questions coming in here. What are some of the courses for construction engineering? Well, we've got a bunch of those. What I would recommend you do is, if you want to go to the Civil Construction and Environmental Engineering website, you can just put that in any search engine. Just put in civil engineering SDSU and it'll take you there. And then you can actually take a look at some of the master plans that we have, and the curriculum maps, and they'll show you all the courses that you need to take for any major within the department. And you can do that for all of our departments here in engineering. If you just want to go to our main site, engineering.sdsu.edu, you can take a look at all of our departments, and then from there you can see all the degree maps and all the courses that you'll have to take and all that, so you can kind of give a comparison. You can also go to MyMap, which you can just put in a search engine, MyMap SDSU, and then that'll let you compare degrees. You can take a look at anything on the whole campus, not just engineering that way, but you can look and say, hey, I want to try to figure out the difference between, say, construction management and construction engineering. You can take a look at the difference in those courses. Or if you say aerospace and mechanical, and you can see, pick and choose and see between different majors and compare those and see what courses you're most interested in. Let's see, what else do we have here? What are the average class sizes for engineering specific courses and lectures? So I think by that you mean we're getting down into your upper division courses. Those will get lower. I'd say most of those courses are going to be in the 20 to 50 range. I don't know if anybody else wants to jump in on that and talk about their own course sizes. And it looks like we also have another question there. Is the out-of-state admission 32%? I think admissions can follow up on that maybe.
Yeah, so unfortunately, we don't have the specific acceptance rate for in-state and out-of-state or per major. 32% was just roughly across the board for all first year and transfer students. What I can do is send a website in the chat box if you wanted to see for fall 22 how many students applied for every major, how many were accepted per major, and then how many actually enrolled. So I can provide that information, but just overall, roughly, it's about 32%, and the applicant pool does differ every single year. So it does vary, but I'll send that link in the chat.
Yeah, great. We got that link down there to ASIR, which has a lot of the data for SDSU there, and you can drill down into that and have fun with a lot of the information for all of our majors at SDSU. I think we had another question there about somebody that's interested in mechanical engineering, but if they want to switch to say like electrical, as they're suggesting, it's certainly possible. The longer you wait in making that decision, it becomes much harder to do. So we do recommend making that decision as soon as possible, preferably in your first year at SDSU. But we can certainly help you through that process. All of our major advisors, our peer advisors, myself, will all help you figure out what it is that you really want to do. And if that decision comes that you want to switch majors, we'll help you through that process. So definitely something, like I said, you want to make that decision as early as possible in your academic career. All right, what's the average GPA for an engineering major at SDSU? 4.0, of course. What else could it be? Anybody want to jump in on the average GPA for an engineering major?
It depends whether we're talking about the admissions or the engineering majors already being the enrolled students. So I think probably this is related to the enrolled students. And right now it's about 3.2.
Yeah, I like to say anything above a 3.0 is great for engineering. Yeah, it's fantastic that our students are in that 3.2 range and increasing. So let's see, what other questions do we have here? Are there specific courses that all engineering majors have to take? For the most part, you're doing the foundation of engineering, which is going to be calculus, differential equations, that sort of thing. For most of our majors, you're also going to be taking physics and chemistry, with the exception of electrical and computer engineering there. So those are generally your foundation courses that you take, and we also have some general education courses that all students are taking as well. All right, we got some questions answered there about GPA, whether your applicants coming in and what it is.
Yeah, this I think this comment about GPA is related to the GPA of the students as they are coming. So what I was talking about, the average GPA of enrolled students that they already earned as university students, as undergraduate students. So that's GPA of their performance in the university. And at the admission, you can see that weighted 3.97 for first year students and 3.4 for transfer.
Any other questions we can answer for everybody here? Well, we've got you all. I think we didn't talk too much about our grad programs, but I'm going to throw that in there real quick too, is that we've got some great master's programs here too, if that's your eventual interest. I know you're still very, very new coming into all this, but we do want to emphasize that we have, you can continue on your educational pathways here, right on into graduate degrees, all the way to PhD if you want to join it. We have a joint doctoral program with UCSD, and we do pick up students right out of the undergraduate programs for that. So if your interest is eventually getting into doctoral level research and maybe becoming a professor, going out and doing some high level research, we've got a great program there for you too. This is a great institution to stay at and achieve those goals. So, and we pay for the whole thing too, which is a great thing. So. So you got another question there. How early can one start doing an internship? You could start doing that your first year. There are some early internships out there. Of course, some companies want to see a little bit of experience or a little bit of engineering knowledge under your belt there. I'd say typically the time that most students get at an internship is starting in their junior year, but absolutely first year you want to go out there and get an internship, talk to our internship coordinator, and we'll be able to make that happen for you.
Donovan, maybe you want to mention something about the San Diego State University summer research program, which is encourage freshmen to.
Yeah, our summer research programs, we've got a lot of opportunities there, folding into the broader undergraduate research. Basically, I'll talk to your professors once you get here, and we want to encourage everybody to get into our labs and see what's going on there. So many different opportunities available to you. So once you get here, definitely talk to the faculty and all of they're teaching your classes. Go into their labs, see what's going on down there. Lots of research opportunities, whether it be in the summer or throughout the academic year. So I want to highly encourage that. If anybody wants to jump in and add anything on that, please do.
Yeah, there are multiple opportunities for students to be involved in research projects conducted by our faculty. But whether they are graduate or undergraduate students, those opportunities are plenty. And students actually are encouraged to get in touch with faculty members and get and become members of their research teams. Okay, any more questions?
Do engineers get to wear the iron ring during graduation? Yes, absolutely. That's the Order of the Engineer. We took unfortunately a little bit of a break over COVID in doing that. It was a little difficult, but we are going to be back and doing the iron ring ceremonies. So if you do want to wear that ring, once you're getting closer to graduation in a few years, you can come talk to me and we'll make sure you get that iron ring. We got another question there. Is it possible to minor in something outside of engineering, like a language? Absolutely, yes. If you want to add a minor to your degree, it does have to be outside of the College of Engineering. If you're an engineering major, you can do that. And a lot of our students will do that. If you want to pick up a language as a minor, you can do that, or something over in sciences. You want to get a physics or math or chemistry or geology, something like that, or even go off and get literature or music or something. You can absolutely minor in that at SDSU. So if you want to do that, definitely talk to your advisor once you get here, and they'll help you go down that process of getting that minor. All right, any other questions we can answer for everybody here? Yeah, I'd like to thank everybody for coming. If there's any other comments from our panel here or anything, anybody like to throw in one last thing before we sign off here?
Thank you for attending this preview session. Please watch our also SDSU Explore activities, which are organized for admitted students in spring. So that will be actually conducted in person. So you will have opportunities like the open door, open house format to actually visit our labs and be talking to individual faculty, to administration, and also ask any questions at that time. So thank you for attending and best wishes.